Hey everyone, welcome back. So we're solving another lead code question today. It's called as Unique Path 2. This is part of my DP playlist and a DP series. And yeah, before we get started, just one disclaimer. I've not solved this question before, so if you see my submissions, I don't have anything. Right? I'm gonna be solving the questions with you so that if I'm stuck at any point and I try to figure out the solution for that, and if you're here because you're also stuck at the same point, it'll be easy for you to debug and learn where you're going wrong, right? Okay, so let's get started. So this unique part 2 is it is a sequel of unique path 1, right? I would suggest you to solve unique paths and then come to this question. If you don't, you're not going to understand this and there's no point of solving this, right? So I would suggest you to solve that first and then come to this. Perfect, right? So you're given a m into n grid, right? Okay, and then you have a source and then a target, right? The difference in this question is that the values that are there in the grid are filled with either 0 or 1s, right? Yes, right. So it's filled with 0 1. The last question didn't have any values to it because we were trying to figure out the number of ways you can reach the target, right? Okay. Now an obstacle and a space marked as 1 or 0, right? An obstacle is marked as 1 and a space is marked as 0, right? The path that robot takes cannot include any square that is an obstacle, right? So what you're supposed to do is the same thing. You're supposed to figure out the number of unique ways that you can reach the target without hitting an obstacle, right? The same thing, okay? And also another constraint is that you can move only in one direction. You can move only in two directions. That is either you move towards the right, okay, or you move down, right? You cannot move left and top, right? These two are the only directions that you can move. Okay, now let us take a look. So this will be 0 1 2 and 0 1 and 2, right? Zero zero zero, 0 1 0 and 0 0 0. Okay, so now we need to figure out how to reach from the source to the target. That is, this would be my source, right? And this would be my target. Okay, now in the last problem, right, we had two ways to reach this point, right? That is in unique path 1, right? Now it's the same thing. We have two ways to reach over here, but just with one extra condition, and that condition would be that if any of the path, right, if any of the path which leads to the target has an obstacle, like let's just say that you have two ways to reach here, and now my new target becomes this, right? So this is my new target. I have two ways to reach here, right? One is from this side, one is from this. But the thing is, I should not consider this path, as this path is considered as an obstacle, right? I cannot reach here with this particular path. Okay, so this is my only path, right? The same thing. Okay, now let's try to solve it. Okay, what am I going to be doing is it's the same thing, right? So I'm going to be having public int unique, and let me just call it path of int array array, right? And int row, int column, right? And then I'll come to the base condition later. So what I'm going to be doing is I'm going to be checking, right? If maybe what I can do is I can have yeah okay, what I can do is I can have int path 1 is 0, right? No, I call it different. Path 1 is 0, right? And then int path 2 is also 0, right? Initially, right? If if array of row minus 1 column is not equal to minus 1, it's not equal to 1, then what I'm going to do is I'm going to be calling path 1 equals to paths of array and then row minus 1 column, right? If array of row and column minus 1 is not equal to minus 1, is not equal to 1, right? I'm going to be calling path 2 equals to paths of array comma row comma column minus 1, right? Here I'm just going to return path 1 plus path 2, right? Okay, now there's going to be a small issue. What is it, right? In the last problem, what were we doing? Right, in the last problem, what were we doing? We were saying that, right? We were saying that if I reach either 0th row, either this point or this point or this point or this point or this point, I'm going to return one path in the last problem, right? But over here, it's going to be different. Why? Because it can have one path, it can have 0 paths as well. So that what I mean is, right? If let's say that this is 1 and this is 0, right? And this is my target now. How many ways are there to reach this path? There are 0 number of ways to reach this path, right? There are 0 number of ways to reach this path. Perfect. Right? Now, how many ways are there to reach this particular path if this is 1? This is the target. There is 0 number of ways because this is an obstacle. You can only come this way, and since this is an obstacle, you cannot reach this path. Similarly to this, you can only come this way. Since this is an obstacle, you cannot. Since this is an obstacle, you cannot reach this path, right? So I can't do that, right? I can't just say if row equals 0, column equals 0, return 1. What I'm going to do, I'm going to run the condition until your value becomes less than 0. Whether what I mean is for this one, it's going to pick this one. This one, there's no path, right? So this one, there's no path, right? Basically, so for this one is not valid. Okay, so oh yeah, I need to do one more thing actually. If so, here there's going to be another condition, that is greater than 0, row minus 1 is greater than 0, and this condition would apply, right? If column minus 1 is greater than 0 and this condition would apply, right? Only then this condition would apply. So this case, what would happen is it'll come here. It's not never going to make a call, right? And then it's never going to make a call. This call will never be made, right? So this call will never be made. Okay, now what will happen is this particular thing, it can either come from here, and it can't come from here because this is wrong, right? It can only come from here. So yeah, so yeah, yes. So from here, so this was 0 and this was 0, right? If I'm not wrong. Yes. Okay. So now let's see over here. I can only come this way, right? I can only come this way. Now this will become the target, new target, right? Now I can only come this way. Now this will become the target. I can only come this way, right? When I come here, what I'm going to do? I'm going to return 1. Okay, I'm going to return 1, right? Similarly for this particular path is not possible. Okay, so it can only come from here. This will become my new target, right? Similarly, this, it can only come down. This will become my new target. Similarly, this will become my new target, right? So I need to return 1. So if my this thing is if my row is 0 and my column is 0, I'm going to return 1. So if you see, our answer is 2. Which 2 are the paths that we found? It was this one, right? And also this one. These 2 are the only paths. Okay, now what am I going to do? My base condition will change into if row equals 0 and my column equals 0 and my column equals 0. What am I going to do? I'm going to return 1. Okay, now path 1 plus path 2, return path 1 path 2. Okay, now what am I going to do here? I'm simply going to return paths with obstacle grid, right? Row is obstacle grid dot length minus 1, and column is obstacle grid of 0 dot length minus 1, right? 0 dot length minus 1. Okay, perfect. So it'll be 3 cross 3, so 2 and 2, 2 and 2. Perfect. So this should run, right? Well, yeah, let's see. Okay, part 2. Okay, I think that's it. Okay, both of them gave me wrong answer. This is returning. Okay, I'm not sure. It should be greater than or equal to 0. Greater than or equal to 0. Perfect. Right? It's greater than or equal to 0. Right? Because row minus 1 should be greater than or equal to 0. Right? Perfect. Now, if I try to submit it, it's going to fail because we discussed the same reason why. If you haven't watched my previous video on unique path, please watch it before you come to this, right? Or else it's not going to make a sense, right? Okay, I got a wrong answer over here. That is expected as 0. Okay, so 0 0 then 0 1. Okay. Oh, there's one more edge case. My target can also be 0. sorry, my target can also be an obstacle, that is 1, not 0. My target can also be an obstacle, right? Right? Okay. Okay, we can handle that. What we're going to do is we're going to do something, right? Int rho equals to, we're going to pull this out. We're going to pull this out, and right, int column equals to, pulling this out, right? If obstacle grid of row of column equals to 1, I'm going to return 0. Okay, else what I'm going to do is I'm going to return row, and then I'm going to return column. Okay, let's use this test case and let's see how it works. Okay, so I never expected my target to be an obstacle, right? Okay. Right, it's gonna fail again. We got a TLE, right? Why we got a TLE? We discussed it in the last problem, right? Your values can go up till 100, right? So if you're forming a recursive tree, it will be on each level it'll keep increasing by 2 power I plus 1. Like on the first level it'll be 2 power 0, on the second level it'll be 2 power 1, right? Third level till nth level it'll be 2 power n, right? Since this is a matrix of n into m, it's going to be 2 power n into m, right? So what's going to happen? It's going to throw us a TLE, because on the worst case, if you're taking 2 power 100 cross 100, it's a huge number, right? So this is where we're going to introduce our DP. So what we're going to do is simply we're going to simply have a DP array, right, of the same size. Okay, so we're going to have a DP array of the same size, right? Now let me create it with the same length actually. So int dp equals to new int of obstacle grid dot length g, right? And then for the column will be, right? Now what we're going to do is, can our answer be 0? Can there be 0 paths to reach the target? Yes, there can be 0 paths in this case, because if you consider all these scenarios, if there are obstacles everywhere, there are 0 ways to reach the target, right? So since it's defaulted with 0, our DP array, we cannot have it like that, because it's going to create a confusion if it is a default value or if it's actually the value to reach that particular grid. So what we're going to do is we're going to iterate through the array for int val row 0, row less than dp dot length, and then row plus plus, right? For int column 0, column less than dp of 0 dot length, and then column plus. We're gonna set dp of row and column to be minus 1, right? And then here we're gonna pass dp as a param, and here we're gonna receive dp as a param as a 2D array. Okay. Now what we're gonna do is, before anything, we're gonna check if dp of row column is not equal to minus 1, I'm going to return dp of row and column, right? And here what I'm going to do is, this is where I'm returning the value, I need to assign the value, right? I'm going to return. Okay, now here also I need to pass it as a param. DP, and here also I'll pass it as a copy DP. Okay, and okay, I think it looks good. Let's try to run. Try to use a test case which failed. Okay, we got an error. Okay, I believe it's being used. Right. I'm going to use it as ing. I plus j, j, and j plus plus of I and of j is -1, right? And then I'm going to be passing. Okay, perfect. Yeah, it went through. Now if I submit it, it's going to go through and it should hopefully be accepted. Yes, got accepted. Perfect. So this solution would have a time complexity of n into m. Why? Because on the left subtree it would process all the values and store it in the DP array, right? And then when it comes to the right subtree, it's going to fetch that value and then return it. That'll be of one operation, right? So our total time complexity would reduce to of n into m, but our space complexity would be of n into m, right? We can reduce space complexity using bottom-up approach, where it can be reduced to of I believe of m, right? Because you just need one particular row, right? And each row is going to have the values of if it's possible to reach that particular grid or not, right? I'm not going to do the bottom-up approach over here because it's ideally the same formula, right? We have found the recursive relationship, right, over here, path 1 and path 2. It's going to be the same formula. It's just that you can tweak it a bit to handle the base conditions, where initially you would have a base condition and you need to handle that, and then you need to reach the end of it, right? So I would suggest you to go through that and then try doing it on your own, right? Thank you so much for watching.